All right, so today we're going to look at how to take this equation. This is the equation for a specific heat capacity that we use in physical science. And we actually have a foldable to help kids be able to see how to manipulate the variables in here when they're trying to solve specific heat capacity problems. This is the equation that's given to you on the formula guide. Some students struggle being able to manipulate it algebraically, so I have a little nifty hands-on manipulative that you can use to do that. So what I'm going to do is I'm going to take this and put it aside, and we're going to grab a simple sheet of paper, any color you want to, and the way that we do this is we're going to take the two flaps like we're getting ready to fold a paper airplane, and we're going to put these two guys together like so. Forms a triangle at the top. And then you're going to take the bottom of your sheet of paper and you're going to fold it up to meet the base of the triangle, like this. Alright, and you should have a little pentagon shape that looks like this if you did it when you got two flaps right here and one flap right here. Now, the next thing I want to do is I want to take this flap right here on the bottom and I want to divide it into three parts. So I'm going to take my ruler and I'm going to make three flaps like this that I'm going to cut out. Take my scissors and cut along these lines that I just drew. Alright, and once you do that, this will be the basis for your foldable. And we're going to take the variables that we have right here from this, our Q, M, C, delta T, and we're going to put them on the outside of our foldable. So Q, which stands for heat energy that has been lost or gained, we're going to put that in the top part of the triangle. So I'm going to draw a big, huge Q right here. And then my other three variables I'm going to put down at the bottom. All right. Now once we have our variables drawn, then we can fill in the inside of our foldable. So the things that we want to learn, be able to do in this foldable is we want to have all the basic information about it. So Q, I'm going to take it and just open up my flaps like this. And Q, we said stands for heat that is lost or gained within a system. All right, and this could be, you could be heating up some water. You could be, you could have something that's already hot, and you put it into something that's cool, and that object so that piece of metal could lose heat. It's just a measurement of heat energy, and that's heat energy. I should be more specific. Heat energy lost or gained, and we measure this in joules. Okay, so it's measured in joules, and the formula that we use to find heat energy is we're going to take Q is equal to mass times specific heat capacity times the change in temperature. All right, so if the problem is asking you to solve for heat or how much energy is lost or gained, I know that I'm going to just take the mass, multiply it times the specific heat capacity, and multiply it times the change in temperature. Pretty much the same thing as this formula right here. But you're not always going to have to solve for Q. You may have to solve for one of these three variables, and that's why we got the flaps on the bottom. Now the other thing I want to add too is if you do the math and your answer comes out to be a positive Q, that means that the object in the system gained heat energy. And if you do the math and your Q comes out to be negative, well, that would indicate the object lost heat energy. Okay, so there's our Q. So we got our flap on the outside. If we have to solve for Q, I can open this up and it tells me how to solve the problem. M times C times delta T, and I want to make sure when my final answer I have the correct unit, which is joules. All right, so the next flap I'm going to look at is M. M stands for mass. Okay, just how much matter is in an object. All right, so mass, we measure it in grams, little g. Now there are other formulas that that involve kilograms and different temperatures and whatnot, but for this class and the formula that they give us from the state, we are going to be using grams. And if we take our formula right here, the Q equals mc delta T, we're going to solve for M. That would tell us we're going to take our Q and we're going to divide by the product of C times delta T. Now it is very important that I put these parentheses here because a lot of students will miss the math problems because they will not use parentheses on the bottom. They'll just do Q divided by symbol C times and then the delta T, and that you're going to get the wrong answer. You got to make sure that you put this in parentheses, that you have to find the product and then take your heat and divide it by this product. Okay, so if I'm solving for mass, now I know I'm going to take Q, whatever my heat energy is, divide that by the product of the specific heat capacity times the change in temperature. That's what the delta stands for, change. All right, our next one that we're going to move on to is C. C stands for specific heat capacity. All right, now every object, depend on if it's a metal or non-metal, conductor of heat, insulator of heat, they all have different heat capacities. And that just basically means that an object that is heats up very quickly has a very low specific heat capacity. It doesn't take a lot of energy in order to heat that object up, to raise its temperature up. All right, so specific heat capacity, we measure this in joules per gram degree Celsius. So if I'm looking in a math problem, in a word problem, and I see this unit right here, I know that I have been given my C, my specific heat capacity. All right, so if I'm solving for C, in this case it's going to be Q divided by the product of mass times delta T. Specific heat capacity. All right, and then finally we have our last part of our foldable, which is delta T, and that again stands for change in temperature measured in degrees Celsius. We would be using Celsius for this, not Fahrenheit, not Kelvin. That's just what the state says, so we're going to go with what the state says. Now, sometimes in a word problem, they may give you the actual change, but sometimes they don't. They may give you two different temperatures. And if that is the case, we find delta T by taking our final temperature and subtracting the initial temperature from it. They may tell you that they may give you this in the problem, but if they don't and they give you two temperatures, make sure that you read the problem correctly so you know which one is the final and which one is the initial. Okay? So, but if we're actually solving for it when we go to do our math for the problem, delta T is going to be equal to our Q divided by the product of our mass times our specific heat capacity. All right, so Q divided by M times C will give me my change in temperature. And then if I need to solve for the initial or the final temperature, when I find my delta T and one of these is given to me in the problem, then I can just subtract and do what's necessary in order to solve for the other temperature if that's what it's asking for. Okay, so I've got my foldable I can put in my notebook. You can see right here I've got my 4 variables, Q, M, C, delta T, and then depending on what the problem is asking for, I can just flip it over and it tells me right then and there. Appreciate it.